Okay, we're going to get a little bit more practice with component form. So this example says sketch representations of the vector W, which has components 2, 3. So that means from initial to terminal, I need to go right 2 and up 3. So then it's giving me these examples. I want you to start first with initial point 0, 0. So that means that would be something in standard form. And so for vector W, I'm going to go right 2 and up 3. And I'm going to connect those, and that's very good, sorry. There we go. So that would be that vector in standard position. So now we're going to try a vector that starts at 2, 2. So here's 2, 2. We're going to still go right 2 and up 3. We're going to draw that vector. So notice they're equal vectors because they have the same components. They're just starting in a different place. All right? -2, -1 is the next one. So there's the initial. I'm going to go right 2 and up 3. And then the last one is going to start at 1, 4. And I'm going to go right 2 and up 3. So there is the same vector with different initial points. The purple one I did first would be one that we call is in standard position. All right, so now we're going to talk about magnitude. Magnitude is the length of a vector. So when we have something in component form, the A is the x displacement from initial to terminal. So you can imagine here this drawing of a triangle, right? A is how far we're displaced in the x direction, and B is how far we're displaced in the y direction. And so we could think of it as a right triangle and just use the Pythagorean theorem to solve for the length of the vector, which happens to be the hypotenuse of the right triangle. So square root of a squared plus b squared. Be really careful if you're putting this into a calculator. Your components could be negative, but when you square a negative, you always get a positive. All right, the direction angle is an angle measured counterclockwise. So like we did before this year, right, we talked about standard position angles. So if this is the initial side of an angle, if I think about this rotation, we're now going to call that in vector world, that's going to be direction. So we go counterclockwise from positive x. And so in this unit, we're going to use degrees, not radians. So make sure when you get your calculator out for the first time that you are making sure that you measure in degrees. If we go back to this picture for a minute and I'm thinking about finding the direction, that means I'm trying to find this angle between the x component side and what would be the hypotenuse or the vector. And so in order to find that, I'm going to use trig. I know the b and the a, those are my components. So I know that tangent of this angle I'm trying to solve for is going to be b over a. And in order to solve for the angle, I have to use inverse tangent. So theta is going to be inverse tangent of b over a. So when we solve, that's usually how we're going to solve because that's the easiest way using components, using the x and the y components of the vector, we'll use tangent to solve. So our first example, we have a vector with components. So I know it's components because they're v-shaped brackets, -3, 2. So it doesn't tell me anything else. So I'm going to go ahead and just think of this in standard position. So draw it at the origin. -3 tells me I go left 3 in the x direction, and then I'm going to go up 2. And I'm going to draw my vector. I need to find magnitude and direction. So in order to find the magnitude, I'm going to look at these and think about these x and y components. So we have a -3 x component and a 2 for the y. So the magnitude, which let's say that I'm going to call this vector v. When I want the magnitude, we're going to either see usually straight lines around it like this, or sometimes you'll see a double line around it. And that means tell me what the magnitude of the vector is. And so I'm going to find that by doing the square root of -3 squared plus 2 squared. So I get square root of 9 plus 4, which is square root of 13. So that's an acceptable answer. If you're asked to do some rounding, you could just go to your calculator and do the square root of 13, and it's 3.606. So we'd say approximately. So you'll just have to pay attention to how you're asked to give the answer. So that's going to be the magnitude. The direction has to be measured from the positive x-axis. So we're going to measure all the way from the x-axis over here. But we need to use our reference triangle like we did in our other units, and we're going to solve for this little angle in there, that little green angle. So we're going to say inverse tangent of the y component, which is 2, over the x, which is -3, and that's going to give me my angle. So I'm going to go to my calculator, and because I'm solving